Every single time you click your mouse, type on your keyboard, or save a file, you're giving orders. But who's actually taking them? Well, behind that screen, there's this unseen boss running the entire show, your operating system. So today, we're going to pull back the curtain and see what this thing is really doing.
I mean, think about it for a second. That simple little click on the save icon. It feels totally instant, right? Effortless. But in that tiny split second, a whole storm of complex commands are flying around. To really get how that magic happens, we need to meet the mastermind behind it all. So, what even is an operating system, or OS anyway? At its heart, it's this super powerful collection of software that acts as the essential middleman. Yeah, it's the bridge between you, a person, and the raw hardware of your computer. You know, the processor, the memory, the storage drive. It takes your simple requests, like a mouse click, and translates them into a language the machine can actually understand. Now, believe it or not, every single OS is built to do two main things. And what's kind of wild is that, at first glance, they seem to totally contradict each other, but they actually work together in perfect harmony to give you that smooth experience you're used to. This is what's so cool about it. On one hand, the OS's whole job is to make your life easy. It creates that simple, safe, point-and-click world we all know, hiding all the super complex hardware stuff from you. But on the other hand, it's also a really strict manager. It has to control all that hardware, the memory, the processor, and basically act like a bouncer, deciding who gets to use what and when and sorting out all the conflicting requests from your different apps.
So, how in the world does it pull off this incredible balancing act? Well, it does it by performing 6 core jobs, constantly, every single second your computer is on. Let's dive in and break down these 6 critical jobs, one by one.
First on the list is process management. Okay, that might sound a little technical, but a process is really just a fancy word for any program that's currently running. Your web browser, that's a process. Your music player, a process. Even those tiny little background system tasks you never see, yep, those are processes too. You should think of the OS as a master multitasker. It's like a traffic cop for your computer, constantly juggling all your open apps, making sure your processor is never just sitting around doing nothing. It's the whole reason you can have like a dozen browser tabs open while you're streaming music and editing a document. The OS is just switching its attention between each task so fast, it creates the illusion that everything is happening all at once. All right, up next is memory management. This is all about handling the computer's short-term memory, which you probably know as RAM. You can think of it as the main workspace where programs live and breathe while they're running. So, imagine the OS is like a super meticulous librarian for your computer's memory. It knows exactly which shelves are empty and which ones are already taken. When you launch an app, the OS finds it a nice empty spot. And the second you close that program, whoosh, the OS reclaims that space and makes it available for the next task. This constant, super efficient management is absolutely crucial for your computer to run smoothly. Now let's talk about a job you interact with directly every single day: file management. This is how the OS organizes every single one of your documents, your photos, your videos, and all your applications. This is the OS acting as the ultimate filing clerk. Seriously. It's responsible for everything, from remembering where a specific photo is physically stored on your hard drive to controlling who has permission to even open it. It keeps everything neat and tidy in that familiar system of folders and files you use every day. Without it, your computer would just be a chaotic jumble of ones and zeros. The fourth core job is device management. Your computer isn't just a brain in a box, it's also all the physical parts connected to it: your keyboard, your mouse, your monitor, your printer. And guess what? The OS is in charge of all of them. The OS is basically the universal translator between your software and your hardware. When a program wants to print something, it doesn't talk to the printer directly. No way. It tells the OS, hey, I need to print this document. The OS then takes that request, translates it into a language the printer can understand, and manages the whole process from start to finish. Okay, this brings us to a massively important job: security. The OS acts as your system's vigilant security guard, protecting your computer from both internal accidents and, of course, external threats. And this is absolutely critical. The OS builds these digital walls between all your running programs. It's the reason why when your web browser crashes, it doesn't take down your entire computer with it. It stops one app from snooping on another's memory, and maybe most importantly, it protects itself, making sure a buggy op can't corrupt the very core of the operating system. And that leads us right to our final core job: command interpretation. This is how the OS understands what you, the person sitting at the computer, actually want it to do. Every click, every key press, it's a command. And it's the OS's job to understand that command and then round up all the necessary resources to get it done. It's the final piece of the puzzle that connects your physical actions to the digital world inside the machine.
So the OS is doing all this incredible work behind the scenes. But how do we know if it's actually doing a good job? Well, we can measure its performance using a few key metrics.
First up, there's throughput. This is all about pure productivity. It's just asking, how much total work can this system get done in a certain amount of time? Think of it like a factory measuring how many cars it can build per hour. For an OS, it's more like how many jobs it can complete per minute.
Then we've got turnaround time. This one looks at a single task's entire life cycle, from beginning to end. It's the total time that passes from the moment you submit a job, say rendering a video, until the moment it's completely finished. This includes both the time it spent waiting in line and the time it was actively being worked on. And finally, there's response time. And honestly, for us, this might be the most important one for how fast a computer feels. This isn't about how long the whole job takes, but how long you have to wait for the first sign of life. When you click an icon, it's the time until you see that little loading cursor pop up. A low response time is what makes a system feel fast and snappy.
Okay, let's connect all these ideas to the real world. I mean, these aren't just abstract concepts in a textbook. They're the exact design principles that built the operating systems you and I use every single day. Just look at these examples, right? MS-DOS was all about raw command interpretation. You had to type out every single thing you wanted it to do. Linux is famous for its rock-solid security and efficient resource management, which is why it's a huge favorite for servers that need to be stable. And the original Macintosh OS, its #1 goal was to be easy to use, so it focused on creating a great graphical interface that did a fantastic job hiding all that hardware complexity. See? Each OS makes different choices about which of these core jobs to prioritize.
So the next time you're using your computer, just remember that unseen boss working away in the background. It's constantly making thousands of decisions every second, always balancing performance, security, and ease of use. And that leaves us with a final thought to chew on. What would your digital life even look like if your OS prioritized one of those jobs above all the others? I mean, what if it chose ultimate convenience but had to sacrifice security to get there? The particular balance it strikes, well, that defines our entire experience.